Hello everyone, this is Rahul Chaturvedi and you are watching Telecom Notes. Guys, please subscribe this channel and stay connected for the upcoming videos having a lot more regarding the LTE. Okay, so today we are discussing about the RRC layer. Earlier we have just done the protocols and let's start. Starting from slide 1, this is the RRC functions. So in RRC functions, the first point is broadcast to system information. The second one, RRC connection and configuration control. Third one is the paging. Fourth, initial security activation. RRC connection mobility handovers. Recovery from radio link failure. Measurement, configuration and reporting. Generic protocol error handling. RRC control messages. And in the RRC procedure, as you can see, all these procedures are going between LTE, that is your handset, and E-UTRA, that is from the E node B side. The first one is the system information, broadcasting of system information, scheduling and notification of changes, system information acquisition of SI messages, connection control, having the multiple points starting from paging, RRC connection establishment, initial security activation, RRC connection reconfiguration, counter check, RRC connection re-establishment, RRC connection release, radio resource configuration, radio link failure actions. Third one is the measurement configuration, layer 3 filtering, measurement reporting. The fourth one is IRET mobility, that is inter-RAT, and the points are handover to E-UTRA, mobility from E-UTRA, inter-RAT cell change, and the other are DL and UL information transfer, UL capability transfer. Coming to the RRC message structure, the first one is the RRC itself, in which you'll find the system information blocks. The second one is radio resource control, that is the configuration of radio bearers, logical channel, PDCP, packet data convergence protocol, RLC, radio link control, MAC, medium access control, physical channels, power control, etc. Third one is security control, that is having the security algorithms with the keys. Mobility control, having other RAT configuration, reselection threshold, etc. Then measurement configuration, report configuration, hysteresis, etc. And other, having the CRNTI, NAS information, transaction identifiers, etc. Now coming to the RRC connection state, the first one is the RRC idle and the second one is RRC connected. So starting from the RRC idle, a UE specific DRX may be configured by upper layers, UE control mobility, monitor paging connect channel to detect incoming calls, system information change and notification, performs neighboring cell measurements and cell reselection or selection, acquires system information. Now coming to RRC connected, in RRC connected you will find transfer of unicast data to or from UE, network control mobility, that is handover and cell change order with optional network assistance NACC to GRAN, monitors a paging channel and or SIP type 1, that will be just discussed in the next video of SIP, contains to detect system information change notification, monitors control channel associated with a shared data channel to determine if data is scheduled for it, provides channel quality and feedback information, performs neighboring cell measurement and measurement reporting. acquires system information. Okay, coming to the broadcast of system information. As you can see here, first one is the MIB. In MIB contains a limit number of most essential and most frequently transmitted parameters, that is pH configuration, DL bandwidth, and subframe number. And for the system information, come to the first point first. System information is divided into two parts, that is MIB and SIPs. SIP we have discussed right now, that we get the value of pH configuration, downlink bandwidth, and the subframe number from which your UE starts reading that particular messages. So now after MIB, after reading that particular master information block, it comes to the system information blocks containing the main system information, example, cell identity, PLMN identity, tracking area code, etc. It also includes the scheduling information for all other SIPs. Coming to the MIB scheduling, the MIB uses fixed schedule having the periodicity of 40 ms, repetition made within 40 ms. The first transmission of the MIB is scheduled in subframe 0 of radio frame, in which the subframe number mode 4 should be 0. Repetition are scheduled in subframe 0 of all the other radio frames. Connection control scenarios. Paging to transmit paging information to a UE in RRC idle, and or it inform UEs to RRC idle and UEs in RRC connected about a system information change. RRC connection establishment, to establish a RRC connection. Initial security activation, to activate AS security upon RRC connection establishment. RRC connection reconfiguration, to modify an RRC connection, example, to establish, modify, release RBs, to perform handover, to set up, modify, release measurements. As part of the procedure, NAS dedicated information may be transmitted from E-UTRA to the UE. Counter check is being used by E-UTRA to request the UE to verify the amount of data sent or received on each DRB. It's data radio bearer. And RRC connection re-establishment, to establish the RRC connection, which involves the reassumption of SRB1, that is signaling radio bearer operation, and the reactivation of security. RRC connection release, to release to release the established radio bearer as well as the radio resources. Coming to the paging, as you can see right now at the right hand side, from E node B, the paging message has been just arrived to the UE. We have just taken an example also, having the message paging record list. UE identity is as TIMZ, that's the temporary ID, and MMEC is the MME code, that is 1. MTIMZ is the mobile temporary ID. Right now I've just written 1234 as an example. CN domain is PS. So paging messages are transmitted on PCCH. PCCH is a logical channel, and that has been just mapped over PCH. PCH is your transport channel, and it's been just mapped over the physical channel PDSCH. PCCH is paging control channel. PCH is paging channel. PDSCH is physical downlink shared channel. Having the RLC transfer mode, TM, transparent mode. PCH support for UE discontinuous reception, DRX. Paging message may contain paging information for UE indicated by UE identity within paging record field. System information change notification when system info modification is true. Coming to RRC connection establishment, it's again from UE to E node B and then E node B to UE. The first one is the RRC connection request, that UE is requesting for the RRC connection to E node B, and then the E node B tries to just set up the RRC connection, and when it has been just set up, your UE just sends the RRC connection setup complete message to E node B. So starting with the points, RRC connection establishment involves signaling radio bearer 1 establishment. The procedure is also used to transfer the initial NAS dedicated information message from the UE to E-UTRA. Timer T300 supervises the RRC connection establishment procedure. Start transmission from RRC connection request. Stop reception of RRC connection setup or RRC connection reject message, cell reselection, and upon abortion of connection establishment by upper layers. Range may be from 100 ms to 2000 ms. So the ranges are 100, 200, 300, 400, 600, 1000, 1500 or 2000. Coming to the RRC connection reconfiguration, again in the reconfiguration, the UE sends RRC connection reconfiguration to E node B, and when it has been just completed over there, then E node B confirms the UE that RRC connection reconfiguration complete. The purpose of this procedure is to modify RRC connection example to establish, modify, release RBs, radio bearers. Second, to perform handover, to set up, modify, release measurements. As part of this procedure, NAS dedicated information may be transmitted from E-UTRA to the UE. Coming to the counter check, UE sends the counter check to E node B, and the response has been just sent from the E node B to UE, that is counter check response, used by E-UTRA to request the UE to verify the amount of data sent received on each DRB. The procedure enables E-UTRA to detect packet insertion by an intruder. RRC connection re-establishment, E-UTRA applies the procedure as follows: to reconfigure SRB signaling radio bearer 1 and to resume the data transfer only for this RB. To reactivate AS security without changing algorithms. And at the bottom you can see that UE is sending RRC connection re-establishment request. Then E node B sends the UE that they are re-establishing that particular one. And after that UE sends the message to E node B, RRC connection re-establishment complete. RRC connection release. The E node B sends to UE RRC connection release message. The purpose of this procedure is to release the RRC connection, which includes the release of the established radio bearers all radio resources. The release of the RRC connection is initiated by E-UTRA. The procedure may be used to redirect the UE to another frequency or RAT. The exceptional cases, the UE may abort the RRC connection, that is, move to RRC idle without notifying the E-UTRA. Coming to the radio resource configuration. Sorry, I think I just skipped that particular slide. Yeah. So in radio resource configuration, RRC protocol is responsible for the basic configuration of radio protocol. Radio resource configuration includes SRB addition, modification, release, DRB data radio bearer addition, modification or release, MAC medium access controller main reconfiguration, semi-persistent scheduling reconfiguration, physical channel reconfiguration, Some configurations are handled by layer 1 and layer 2 autonomously. Element group scheduling, EGS, and the radio bearer assignment. Layer 3 example of radio resource configuration, RRC connection setup. As you can see, the RRC message name over here. So as you can see, it's showing the SRB also, SRB identity 1. That's the SRB configuration. Coming to the MAC main configuration, you can see UE scheduling configuration in this, and the physical configuration dedicated, that is the dedicated PUSCH configuration is highlighted by the physical layer configuration. So this is the example we have just taken of layer 3. Coming to the mobility from E-UTRA, UE and eNode B, and eNode B is sending mobility from E-UTRA command. The purpose of this procedure is to move a UE in RRC connected mode to a cell using another RET, example GRAN, E-UTRAN or CDMA 2000 systems. The mobility from E-UTRA procedure covers handover, that is the mobility from E-UTRA command message includes radio resources that have been allocated by the UE in the target cell. Cell change order, that is the mobility from the E-UTRA command message, may include the information facilitating access of and or connection establishment in the target cell. Measurement, configuration and reporting. Measurement objects such as examples are single E-UTRA carrier frequency in intra or inter-frequency measurements, set of cells on a single E-UTRA carrier frequency in the IRET E-UTRA measurements, set of GRAN carrier frequencies in IRET GRAN measurements. Reporting configuration, reporting criteria and reporting format. Measurement identities, quality configurations, measurement gaps, establishment, modification or release of measurements, that is intra-frequency, inter-frequency and IRET measurements, setup and release of measurement gap. Here you can have a look over the layer 3 measurement configuration. In this we have just highlighted the measurement object, reporting configuration and measurement identities. So this is just an example. Coming to the measurement report now. Measurement reported has been just sent from the UE to eNode B. It may be having a particular amount of time that has been just going through the repetition of that particular procedure again and again, or it's not the mandatory one that you have just put it to reach the eNode B and send the measurement report again and again after a particular amount of time. So it depends on the operator, or when you have just turned on the measurement to just send at a particular amount of time, it will just keep on reporting, otherwise it will report by its own. The purpose of this procedure is to transfer measurement reports from the UE to E-UTRAN. It's multipurpose message containing measurements result for serving cell, neighboring cells, optionally E-UTRA, E-UTRA, GRAN and CDMA 2000. And here you can just have a look about the RRC signaling messages, that in each and every message how RLC mode works, acknowledge mode, transparent mode, it's mentioned over here. SRB type, that is signaling radio bearer. The direction that the message is sending from the E-node B side or from your mobile side, and what are the logical channels that keep on supporting for sending that particular message. So in this we have just mentioned RRC connection request, RRC connection setup, RRC connection setup complete, RRC connection reject, RRC connection reconfiguration, RRC connection reconfiguration complete message, RRC connection re-establishment request, RRC connection re-establishment, RRC connection re-establishment complete, RRC connection re-establishment reject, RRC connection release, MIB and SIB, master information block and system information block. Coming to the RRC signaling messages and signaling radio bearers. So SRB0 is working over the CCCH, that is the common control channel. Content is it contains that particular RRC messages. Coming to SRB1, signaling radio bearer 1, it's been just generated when it is just connected to your particular device, that is the dedicated. So it just keep on moving for the logical channel. It's DCCH, dedicated control channel, having the RRC messages, piggyback NAS messages also. SRB2 is again on DCCH, dedicated control channel, having the only NAS messages. Note, and SRB1 RRC message may carry the NAS message if SRB2 is not yet established. Again, the note, SRB2 NAS messages are contained in RRC messages, example DLUL information transfer. So guys, that's all from my side. Thanks for watching the video, and please subscribe for the upcoming videos. You will get a notification. Thank you.